Hi friends, welcome to Learner's Planet. Friends, this is our second session for basic concepts on triangles, lines, quadrilaterals and other polygons. You might have attended the previous session. If not, then do not attend this session before you complete that particular session, because the basics must be clear. Okay, so in this session we'll be discussing more terminologies, concepts and theorems related to all of them. So let's begin the session, and whatever the important points you find during the session, just note them down. Okay, so this will be able to make a very nice notebook. So let's begin the session. Now let's start with basic properties of triangles. The first is the angle opposite to two opposite equal sides of a triangles are equal. Okay, I just show you. Suppose I have this triangle A, B and C. Now if AB is equal to AC, if AB is equal to AC, that means this side equal to this side. That means the angle opposite to A, both of them will be equal to each other. That means angle B will be equal to angle C. Okay. Similarly, if AB is equal to BC, then angle opposite to B will be equal. Okay, so if AB is equal to AC, angle B will be equal to angle C. So angle opposite to two equal sides of a triangle are equal, or we can say if the two angles of a triangle are equal, then the sides opposite to them are also equal, right? That is vice versa is also true. So if you are given that angle B is equal to angle C, that means AB is equal to AC. Okay. Then the third important point is if two sides of a triangle are unequal, the longer side has greater angle opposite to it, right? Here we can say the three sides AB, AC and BC. So if AC is greater than BC and greater than AB, then the angle opposite to AC will be greatest angle, then angle BC, the angle opposite to BC, then angle opposite to AB. Okay, that means over here if side AC is the greatest, then angle opposite side AC is angle B, so angle B will be greatest. Then we have in order side BC, so angle opposite to side BC is what? Angle A. Then the remaining one is angle C. Okay, so the two sides of a triangle are unequal, the longer side has greater angle opposite to it. Now we discuss some more terminologies for a triangle. That is altitude, then we have median, then we have angle bisectors and some more. Okay, so first of all we see altitude. Altitude is actually, I just draw an altitude. From this vertex, if I drop a perpendicular on opposite side, that it is known to be altitude or height of the triangle, right? So if this is a triangle ABC, ABC and AP is perpendicular on side BC, then AP is altitude. Okay, AP is altitude over here. Similarly, from point B, if we drop a perpendicular on side AC, that will be altitude on side AC. Okay, similarly from vertex C, if we drop a perpendicular on side AB, then it will be an altitude on side AB. Okay, now you can see altitudes of all the three sides, or altitude on the three sides, they are concurrent, right? Suppose this is P, this is Q, then this is R. That means BQ, AP and CR, BQ, AP and CR, they pass through a common point, right? And this common point is known as orthocenter. That is, concurrence point of altitude is known as orthocenter. Orthocenter is what? Concurrence point of altitudes. And what is an altitude? It is height of the triangle. Okay. So orthocenter is concurrence point of altitudes. And what is an altitude? That is height of the triangle, or up if you drop a perpendicular from a vertex to opposite side, that is actually altitude. So here AP, BQ, CR, all of them are altitude of this triangle. You know the area of the triangle, that is half base into altitude. Okay, you just take height of the triangle or whatever. So here, if this is the base, AC is the base, then BQ will be altitude, right? So you can find out the area of this triangle as half AC into BQ. Similarly, if BC is the base, AP will be altitude. So the area of the triangle will be half BC into AP. Similarly, the third side, half AB into CR. In the three cases, you'll be getting the value of the area of the triangle as same, because area of the triangle will be constant, obviously. Okay, so you can find out the area of triangle in any manner. So half base into altitude. Concurrence point of altitudes is orthocenter. This is a very important term. You must be knowing this. As a definition also it can be asked. Let's see the next one. Next is medians. Now what is a median? I draw, then I just tell you. This, and this. Now I just explain the triangle ABC. This is ABC. Now this is PQR. And what is special about PQR? P is the midpoint of BC, right? P is the midpoint of BC, Q is the midpoint of AC, and R is the midpoint of AB. So precisely what is a median? A line that joins the vertex to the midpoint of opposite side, right? Midpoint of this side is P and vertex A. So AP is a median, BQ is a median, and CR is median, right? P is midpoint of BC, CA is Q is the midpoint of AC, and R is the midpoint of AB, right? And the line joining the vertex, opposite vertex, or the vertex to midpoint of opposite side is known to be median. Okay, so BQ, CR, PA, these are medians. PA, BQ, and CR, these are medians. Now one important thing, as in the previous case when we discussed altitude, the concurrence point of all the altitudes is orthocenter. Similarly, the concurrence point of all the medians is known to be centroid, right? Concurrence point of medians is centroid. Okay, so this is what a centroid. Okay, now one important property of this centroid is it doesn't actually bisect the medians. It divides the median in the ratio 1:2. So this is 1, this is 2. Okay, start from the vertex. The vertex part will be 2 part and the side part will be 1 part. So this is 2, this is 1, and this is 2, this is 1, right? So AG is 2, GP is 2:1. Centroid divides the median into 2:1 ratio when 2 is apart from vertex side. Okay, so that should be clear in your mind. That's very important property. Once again, concurrence point of medians is known to be centroid. What is a median? That I have explained to you. You can just this way. Okay, I hope you are getting it. Next is angle bisectors. it itself implies what is an angle bisector. Suppose I have the side of the triangle ABC, then this is angle B, this angle is equal to this angle is equal to this angle, and this angle is equal to this angle. That means AP, BQ and CR are angle bisectors, right? AP, I just write AP, BQ, CR are angle bisectors. That means the line that bisects the opposite angle, right? Here the line BQ, it is bisecting angle B, line AP bisecting angle A, line CR bisecting angle C. So this is what these are what angle bisectors. Similarly, we name angle the concurrence point of angle bisector, as we have done in the case of altitude, that was orthocenter. In case of medians, the concurrence point of medians was centroid. Similarly, concurrence point of angle bisectors is in center, right? Concurrence point of angle bisectors is in center. So this is precisely an in center. Now what is special about in center? See, if you put a compass over here and if you try to make a circle, you'll be able to make a circle that will touch all the three sides of the triangle. Okay, so this is very important. Okay, so concurrence point of angle bisectors is in center. This is an in center. We call this circle as in circle. In circle means a circle that is inscribed in a triangle. A circle that is inscribed in a triangle. Now a circle that is inscribed in a triangle means the circle touches all the three sides of the triangle. So that is in circle. In center, in circle, and the radius of this circle is known to be in radius. Okay, so you must be knowing all the terminologies: in center, in circle, in radius. We have so many properties for in center, in circle, in radius. So if at all it is not clear in your mind what exactly in center is, you will not be able to solve the problems. I can give you a very simple example over here. Suppose in any exam you are asked a question, maybe this angle, suppose angle A is 50 degree, then, and suppose this is I, then what is angle BIC? Angle BIC is what? Now how do we approach this? Now if you know the property of in circle and in center, then you can easily do it. Now if this angle is 50 degree, this angle is 50 degree, that means angle B plus angle C should be 130 degree, right? This complete angle plus this complete angle should be 130 degree, because sum of the three angles of a triangle is 130 degree, right? So this plus this is 130 degree. That means half of angle B plus angle C will be 65 degree, right? Because this is what? The concurrence point of angle bisectors, right? So this plus this will be 65 degree, only this portion. Okay, do not get confused. This is the complete angle, this is the complete angle. Half of this plus half of this is 65 degree. Now further we have a triangle BIC. So if this angle is 65 degree, this angle is 65 degree, total it is 130 degree. So this must be 50 degree. Okay, so if you know this property, or that the concurrence point of angle bisectors is in center, then you can easily do this sort of problems. Okay, so this is just a small example. You'll be able to do the tedious problems once you are conceptually clear. Next in the line is perpendicular bisectors of sides. Now what is perpendicular bisector? Suppose we have this triangle ABC. Just write it down. I have this triangle ABC. So if you put your compass over here and put an arc over here, and from this point just make one arc, Okay, so this line will bisect, this line will bisect line AC, okay, and go somewhere over here. Similarly, the same thing, if you put a compass over here, you'll be getting a point, you'll be getting this point, and similarly this, and similarly this. So if it is P, it is Q, it is R, then, and it is O, then OP, OQ and OR are perpendicular bisectors. That means this angle is 90 degree, this angle is 90 degree, this angle is 90 degree. BR is equal to RC, PC is equal to AP, and AQ is equal to QB, right? So these two sides, these two parts are equal, these two parts are equal, these two parts are equal. So we know them as perpendicular bisectors, right? And how do we draw a perpendicular bisector? That I have already explained. Okay, now as we named the concurrence point in case of median altitudes and this angle bisector, similarly in the series, the concurrence point of perpendicular bisectors is actually circumcenter. Very important. Concurrence point of perpendicular bisectors is circumcenter. So this O is what? It's a circumcenter. Okay, now what is special about it? The circumcenter, it is equidistant from all the three vertices, right? That means OA is equal to OB is equal to OC. OA is equal to OB is equal to OC, right? And if you put the point of compass over here and the pencil over here, you'll be able to draw a circle like this. I'm not able to draw a very clean circle, but I hope you are able to understand this. So you'll be able to get a circle like this. Okay, so this is known to be circumcircle. This is circumcenter, this is circumcircle, and as I told you, OA, OB, OC will be equal. OA, OB, OC will be equal. These are known to be circumradius. Okay, so this is once again very important. Concurrence point of perpendicular bisectors is circumcenter and circumradius, you know, and this circumcircle, right? So circumcircle can be described as a circle that is inscribing a triangle, or we can circumscribing a triangle, right? So we have triangle ABC, we have a circle that is circumscribing the triangle. That means all the three vertices of this triangle are there on the circumference of the circle. That's why it is circumcircle. Okay, the important thing is all the three vertices of the triangle should be there on the circumference of the circle. Then it is known to be circumcircle. Okay, any other random triangle like this will not be circumcircle. In that case, it is not a circumcircle. Okay, all the three vertices should be there on the circumference of the circle. Okay. Next in the series, midpoint theorem, very important. The line segment joining the midpoints of two sides of a triangle is parallel to the third side and equal to half of it. Okay, suppose P is the midpoint of side AP and Q is the midpoint of side AC, and PQ is parallel to BC, then PQ will be half of BC. Okay, so that's very important. Similarly, we have converse of the theorem. The straight line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side, right? Suppose from point P, that is midpoint of AB, if I draw a line that is parallel to the third side, and if it bisects, then it will bisect the third side precisely. I just do it once again. If I am drawing a line from P is what? The midpoint of AB, okay, and parallel to this, that is BC, then it will bisect AC, okay. So Q is the midpoint of AC. So this is what the midpoint theorem. Now let's discuss Pythagoras theorem. If we have a triangle A, B, C, and over here this angle is 90 degree, that is one of the angle is 90 degree, then we call it as a right angle triangle. Okay, now if the triangle is right angle, AB, in this particular triangle I'm talking about ABC, in triangle ABC, AB and BC, they are known to be legs of the triangle, and this is hypotenuse, or in other words we can call AB as perpendicular and BC as base, right? This is angle 90 degree. The side opposite to 90 degree is hypotenuse, and the side containing right angle will be legs of the triangle, and the vertical line is considered to be perpendicular, baseline is considered to be base. So this is a right angle triangle. Okay, so when we have a right angle triangle, we discuss Pythagoras theorem. Well, according to Pythagoras theorem, AB square plus BC square is equal to AC square. That means perpendicular square plus base square is equal to hypotenuse square. That is very important, and you know Pythagoras theorem. So many questions in competitive exams are asked on Pythagoras theorems, right? So base square plus perpendicular square is equal to hypotenuse square. Now when we discuss Pythagorean theorem, you must be knowing some basic Pythagorean triplets. Now what Pythagorean triplets are? See the three numbers which fulfill this condition, that is A square plus B square is equal to C square, we call them as Pythagorean triplet. Suppose I have 3, 4, 5. Now 3 square plus 4 square is equal to 5 square, right? Similarly, I have a 5, 12 and 13. So 5 square plus 12 square is equal to 13 square. So 3, 4, 5, 5, 12, 13 and more of them are there. They are known to be Pythagorean triplets. Okay. Now one interesting thing about Pythagorean triplets are their multiples are also in Pythagorean triplets, right? So 3, 4, 5, that means 3x, 4x and 5x, they will also be Pythagorean triplets. So it is 9x square plus 16x square is equal to 25x square. So whatever is the value of x, that really doesn't matter because ultimately it will get cancelled. So 3x, 4x, 5x. Suppose we take example of 6, 8 and 10. So 3, 4, 5 Pythagorean triplet, that means 6, 8, 10, they are also Pythagorean triplet, double of 3, 4, 5. Similarly 9, that is 3 times of 3, 12 and 50, they will also be Pythagoras triplets. 9 square plus 12 square will be 15 square. So that's an interesting fact. So when you have to do certain problems in which you need to assume the dimensions of a right angle triangle, you can take any of these Pythagorean triplets. Okay. Now let's discuss very important concept, that is similar triangles. So many questions from similar triangles are frequently asked in competitive exams, so you must be clear with the basics of similar triangles. Now what exactly are similar triangles? A triangle ABC and DEF are said to be similar if their corresponding angles are equal and corresponding sides are proportional, right? In fact, if the two triangles are similar, that means obviously their sides will be in proportional. Okay, so suppose I have triangle ABC and triangle DEF. If angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F, then both the triangles, that is triangle ABC and DEF, are similar to each other. right? That means the three angles of this triangle and the corresponding three angles of this triangle, they should be equal to each other, then the triangles are similar, right? And if the two triangles are similar, then their sides will be in proportion. And how do we take the sides in proportion? That is also very important, right? Now suppose angle A is equal to angle D. So side opposite to angle A divide by side opposite to angle D. Okay, then angle B is equal to angle E, then side opposite to angle B, that is AC, side opposite to angle E, that is DF. Okay, then the third side, side opposite to angle C, that is AB, and side opposite to angle F, that is DE. So this is the way you take the sides in proportion. If you just mess up the thing, instead of writing BC over here and AC and BC, if they are interchanged, that will be wrong. Okay, so that is the single way of writing down the sides in proportion. Just take the angles which are equal and take their sides in proportion, opposite sides in proportion. Okay, so triangle ABC is similar to triangle DEF, then BC by EF is equal to AC by DF is equal to AB by DE. Sides, corresponding sides will be in proportion. Okay. Now in any equation, how do we decide whether the two triangles are similar or not? For that we have three similarity axioms. First of all is SAS. SAS, that means side angle side. Side angle side, that means two sides and included angle. This is side 1, this is side 1, and this is included angle. So if SAS, or I just have these triangle. Okay, this side is equal to this side is equal to this side, and this angle is equal to this angle, then the two triangles can be known, can be called as similar, right? So that is SAS, side angle side. Then we have AA, right? Suppose I have this triangle and this triangle. This angle is equal to this angle, and this angle is equal to this angle. Then A similarity, because automatically the third angle will be equal, because sum is restricted to be 180. So if two angles you prove them to be equal, then you can say that two triangles are similar to each other. Similarly we have SSS, that is if the three sides are in proportion, right? I have maybe this triangle X, Y, Z sides, and this triangle AX, AY, AZ, right? So this triangle and this triangle, they will be similar. So if sides are in proportion, then the triangles will be similar. Okay, so when the angles are equal, the sides will be in proportion. If the sides are in proportion, angle will be equal. So both the things are true. Now we see the different results when triangle ABC is similar to triangle PQR. Here you can see this sign, that is a very small wave sort of sign, that is actually sign of similarity. So here triangle ABC is similar to triangle PQR. So when the two triangles are similar, we have already discussed that sides will be in proportion, right? AB by PQ is equal to BC by QR is equal to AC by PR. And how do we take the sides in proportion? That I have already discussed, right? And if the two triangles are similar, angle A will be equal to angle P, angle B will be equal to angle Q, and angle C is equal to angle R. And very important, the area of triangle ABC and area of triangle PQR, the ratio of their areas will be equal to square of corresponding sides, right? So area of triangle ABC by area of triangle PQR is equal to AB square by PQ square, or BC square by QR square, or AC square by PR square, right? And not only sides, but it will be, suppose we have altitudes, then altitudes maybe I just take A, L, B, M and C, N, right? So area will be the ratio of areas will be AL square, and in fact you can say the square of altitudes. then square of medians, then square of angle bisectors, right? That means altitude square, altitude square, altitude square, and the altitudes of the other triangle, corresponding altitudes, right? And similarly corresponding medians, corresponding angle bisectors, right? Just with the help of diagram, I am just showing it once again, where AM and PN are angle bisector. Ratio of areas is equal to AB square by PQ square. AB and PQ sides of this triangle is equal to AM square by PN square, right? That's over there. Okay. Similarly, AX and PS are altitudes and AY and PZ are medians, right? You can see it over here. Altitudes, these are medians, and these are angle bisectors, right? So AB square area, ratio of area will be AB square by PQ square is equal to AX square by PS square, that is medians. Then AY, AX and PX, yes, AX is this altitude, sorry, and AY, PZ is medians. Okay, so you must be knowing all these basics. Next is we have congruent triangles. Now what are congruent triangles? Two triangles are congruent if and only if their corresponding sides and the corresponding angles are equal, right? Here we see ABC and triangle PQR. If we place triangle PQR over triangle ABC, we will not be able to see the triangle ABC, any part of the triangle ABC, right? So these two triangles are known to be congruent, right? Or in other words, we can say if the two triangles are congruent, then they can be imposed on each other, right? Now how do we know whether the two triangles are congruent to each other or not, right? So for that we have test, that is SAS congruence. SAS, that means side, angle, side, right? Suppose side AB is equal to side PQ, side BC is equal to side QR, and the included angle is equal, that is angle B is equal to angle Q, then it is known to be SAS congruence. See friends, the similar triangles and congruent triangle, these are different concepts. In the case of similar triangle, the two triangles are similar to each other in shape but not in size. In congruent triangles, the two triangles are same in size. Okay, so that's the major difference between the two. In case of similar triangles, the angles are equal and sides are in proportion. In case of congruent triangles, the angles are equal, sides are not only in proportion but the sides are equal. Okay, so that is the basic difference between congruent triangles and similar triangles. So do not get confused between the two. Okay, and the next is ASA. Okay, two triangles are congruent if two sides and the included angle of one are equal to corresponding sides and included of the angle of the other triangle, then we call it as SAS congruence. Then two triangles are congruent if two angles and the included side, suppose we talk about angle B is equal to angle Q and angle C is equal to angle R and BC is equal to QR, then also the two triangles will be congruent, right? Angle B is equal to angle Q, angle C is equal to angle R, and the third thing is BC is equal to QR. So to prove the two triangles to be congruent, you need to prove the three things to be equal, and in this manner, not random three things, either SAS or ASA. And the third thing is SSS congruence. That means all the three sides of this triangle are equal to the corresponding three sides of this triangle. Then also the two triangles will be congruent. So SSS congruence, SAS congruence, and ASA congruence. Similarly, if any two angles and a non-included side of triangle are equal to the corresponding angle and side of another triangle, then the two triangles are congruent. Okay, if any two angles, maybe suppose we talk about angle A and angle B, and angle A is equal to angle B P, and angle B is equal to angle Q, and maybe any third side, maybe BC, maybe AC, and it is equal to the corresponding third side, then also the triangles will be congruent, right? Side congruence we have already discussed, and the next very important is the RHS congruence, that is for right angle triangles. So two right angles are congruent if the hypotenuse and one side of one triangle are respectively equal to hypotenuse and one side of another triangle. So that becomes actually a side angle side congruence, right? Precisely, but for right angle triangle we just call it as RHS congruence. So hypotenuse and one side of one triangle is equal to hypotenuse and other side, hypotenuse on and one side, that is corresponding side of other triangle, they are equal, then also they are congruent to each other. So your concept of similarity and congruent triangles must be clear, because questions from both the pattern are frequently asked in competitive exams. This is the sign of congruence. When the two triangles are congruent to each other, they are automatically similar to each other. But if the two triangles are similar to each other, they are not necessarily to be congruent. So you must be knowing the difference between similar triangles and congruent triangles. In similar triangles, the sides are in proportion. In congruent triangles, the sides are equal. The corresponding sides are equal. One more important theorem I have in this session. After that we'll go for the next session. That is actually angle bisector theorem. Questions from this theorem are also frequently asked. Suppose this is triangle A, B and C. This is point P, and AP is angle bisector of triangle A. That means this angle is equal to this angle, right? AP is bisector of angle A, then AB by AC, AB by AC is equal to BP by PC. Okay, that's very important relationship. So you must be knowing this. If AP is angle bisector of angle A, then AB, ratio of AB and AC will be equal to BP is equal BP by PC, right? So that's important. And in the next session we'll be taking formula and all that of triangle related to triangles, quadrilaterals, hexagon, pentagon and maybe other polygons. Okay, so do revise this session and the previous basic session. Next session will also be basic session, but we'll be taking formula and all that. Okay, bye bye.